In this video, we're going to look at reactions of alkyl lithium reagents and also protecting groups and their use in multi-step synthesis problems. So, using an alkyl lithium reagent is very similar to using a Grignard reagent. The electrons between the alkyl group and the lithium are highly reactive, and they will attack the carbonyl carbon, pushing the electrons up onto the oxygen. And so we end up with a negatively charged oxygen and our R group added to the carbonyl carbon. And just like with the Grignard reagents, you're going to want to follow that up with an aqueous acid workup. So nice and simple. So the other really cool use of alkyl lithiates and also Grignard reagents, but mainly alkyl lithiates, is that you can use them to deprotonate terminal alkynes to create alkynide anions. However, you can also do this with sodium azonide, which is something that I hope you recall from CHEM 1. So you can use the azonide to deprotonate the terminal alkyne, giving you the alkynide anion and a sodium counter ion, thus the term sodium alkynide. And these are really useful as nucleophiles. So you can take your sodium alkynide and they will do an addition to the carbonyl, just like we've seen with the alkyl lithiates and with the Grignard reagents. So you have your addition intermediate here. This is often called a tetrahedral intermediate, by the way. I don't think I've mentioned that because we've moved from the trigonal planar starting material to a tetrahedral intermediate product. And then from there, you can actually add in a weak acid, something like ammonium chloride, or you could add in an alcohol, whatever you wanted to do. But if you see ammonium chloride added into a reaction like this, it's just there to protonate the alcohol. And that's it. It looks just like the same type of reaction with a Grignard or an alkyl lithiate. So last topic in this chapter is the use of protecting groups and multi-step synthesis. This becomes really important the more reactions you know, especially when those reactions can, or those reagents can do reactions with many different functional groups. So if we wanted to do this transformation, the change is pretty obvious. We have a carbonyl and we're turning it into a tertiary alcohol. So probably your first thought was, well, let's add in a Grignard. And that's a really good thought because that is ultimately what we want to do. But the problem is if we add in this Grignard, it's not going to attack the carbonyl carbon. It's going to deprotonate the alcohol because we have a strong base and an acidic proton. And acid-base reactions or proton transfers are always faster than any other reaction in organic chemistry. So we have a problem. Now the solution to this problem is to protect the alcohol, right? Cover it up with something that will not react with the Grignard so that we can do the reaction that we actually want to do. So a really useful protecting group for alcohols is the TBS group, which stands for T-butyl dimethylsilane. So you react an alcohol with T-butyl dimethylsilyl-chloride in the presence of imidazole and DMF as your solvent. So TBS is here, TBSCl is when you have a chlorine. Imidazole is just a base, and DMF is your polar aprotic solvent. The aprotic part being really important here. And what that does is it essentially trades out your acidic proton for a TBS group that's not going to be affected by the Grignard at all. And then it's very easily removed using tetrabutyl ammonium fluoride, which is often called TBAF. So tetrabutyl ammonium fluoride in THF as your solvent, and you'll get your alcohol back. So for example, if we wanted to do this synthesis, instead of trying to go straight through with the Grignard, what you should do instead is react with your T-butyl dimethylsilyl chloride in imidazole and your solvent, and that would give you your protected alcohol, and then you have your carbonyl. You can add in the Grignard that you need, so we need to add in an ethyl group, so you could shorthand it with ET and GBr if you wanted to. Follow it up by an aqueous acid workup. Our TBS group is going to be unaffected. We'll have our alcohol, our ethyl group, and then we react with TBAF and THF to deprotect it. So you can kind of remember this by protect, react, and deprotect. It's essentially a Baby Yoda meme. So anyway, that's actually the end of chapter 12.